All right, so this is 3.3, line of best fit. Pretty simple stuff, guys. I think you'll have no problem with it at all. Just like the previous two sections at the end, you're going to see some questions assigned. I just want you to submit photos of your solutions to that. I'm just giving you a rating out of how complete and correct your homework is. Believe it or not, this is the last section that I have to assess you on in this chapter. So, towards the end of this week, I'll probably give you 24 to 48 hours to complete some sort of assessment that I'm going to count as a test. I think just to reward everybody that's been keeping up with the homework, I'm just going to use questions from that homework, kind of just pick my favorites, and it won't be any more than I think you should complete in an hour. But if it takes you longer than that, I'm gonna let you submit answers for, let's say, a day or so, and then I'm gonna cut it off. I'll be more specific when I make that posting, though, about how much time you have to complete the work. All right, away we go. Line of best fit. Now, in this lesson here, I've opted to type in the solutions rather than have you try and read my terrible writing. Line of best fit is a straight line that tries to match the trend in a scatter plot. The acronym is LOBF. So in this first one, as you can see, it's just that straight line that goes from one side to the next. A line of best fit should follow the trend of the data. If the points go up, the line should go up. If the points go down, the line should go down. And this example here that you can see on the left, the trend is down, and so our line goes down. Another quality of a line of best fit is that you should have approximately the same number of points above and below the line. Now, that's approximately. I don't count, especially if you've got, like, I don't know, 30 data points or something like that. You're not going to count to make sure that there's 15 above and below. You're kind of, I hate to say this in a math class, but you're going to kind of do it by feel. As long as your general trend is down and you wouldn't want to put it anywhere bizarre, then that's fine. One of the last things here about lines of best fit is you ignore any outliers. And here we've got our outlier. Sometimes you have a point that just doesn't follow the trend, and you don't force your line of best fit. You wouldn't want to scoop that line down there just to collect that outlier. We saw that once in one of our optimization assignments just before the break, is we had some outliers that we had to just ignore because they didn't follow the trend. And if I'm moving through this too quickly, just make sure that you pause the video to write down everything that you need to write down. Lastly, a line of best fit should pass through every single point if the data is perfectly linear. It doesn't need to start at the origin, and we've seen that in a few of these examples already so far, so it does not need to start at the origin. In some cases, a curve of best fit is actually better than a line of best fit. And you see that a lot in physics. They're either parabolic or linear. It seems to happen all the time. So you've got a bunch of examples of lines of best fit. This is an extremely short lesson. I don't think that there's anything particularly new for you here. I'm just going to try and get my pen rolling. And may or may not work. Anyway, that's all right if it doesn't work. An outlier is a point that's far away from all the other points. If you're wondering, well, how do we know if it's an outlier or not? It'll be obvious if there's an outlier. If all the points are in a straight line, then we say that the relationship is linear. If a relationship is close to linear, then we may call it a strong correlation. And a weaker correlation is going to have the data more spread out. It seems to follow a trend, but the less linear your points are, the less they line up, the weaker the correlation is. In some cases, it's more appropriate to draw a curve of best fit rather than a line of best fit, just to sum up. And if I'm moving too quickly, pause the video, write down what you need to write down. In this particular scatter plot, there is no correlation. How could you tell where to start that if it was positive, negative? Don't draw a line of best fit if you see no trend whatsoever. That would make no sense. And that's about as far as we have to go here without me having to write things down. Well, maybe I'll show you this last example here. So using a line of best fit to make predictions. So here's some data that I just ripped out of the textbook, okay? So it says your mark before your exam and the mark on the exam. Should we see some correlation? Probably. Not very often do people with 95 going into the exam get 45 on the exam. But if you look at the data here, you do see consistently a little bit lower mark on the exam. Right before the exam 84, mark on the exam 80. You know, it's a little bit lower, and we may even see some outliers, right? So graph the data on the grid paper provided. So you guys can graph that if you want. And this one you can just listen also if you want to. You're going to have plenty of graphs to make in the assigned questions, so I'm not too worried about it, all right? So same set of data. Here's some grid paper. Mark on the exam. And I don't know if I can scroll down in order to see. Yes, I can. Here we go. And then mark before the exam on the x-axis, all right? We're trying to see how your mark going into the exam affects the mark on the exam. So the mark on your exam is the dependent variable, and the mark before the exam is the independent variable. And you can see the points are plotted there. We would say that this is a strong linear correlation because very few points fall very far off of that line. And it's a strong positive correlation is how you would say. Strong positive correlation. The higher your mark going into the exam, the higher your mark you get on the exam in general. Right? I don't think any of these points could really be considered outliers. Not really. And anyway, we can continue from there. If we were to count the number of points above and below the line, I don't know. I'm not going to count those points. I'm not doing that. So using that line of best fit on that graph, and we're going to flip back to it a few times, a student's exam mark, if they had 78% going into the exam. Let's look. I'll have to scroll down a bit again. So if we had 78 going into the exam, that would be right before the 80. We could predict that you were going to get around 74 or 75% on the exam, about 74. A student's mark going into the exam if they got about 50% on the exam. So now we're looking at the exam mark and it being 50. So I see 50 right here. And I'm going to go right over, and what am I looking at about your mark going into the exam? If you had 50, it looks like you would have had about 55 or so going into the exam, or 52, I guess was the estimate here that I did before. A prediction like this made inside your data is called interpolation. Interpolation. Use your line of best fit to predict a student's exam mark if they had about 20% going into the exam. All right, so that's outside of our data set, and this is an example of extrapolation, which we'll get to here in a minute. So about 20%. Let's go back. I got to scroll down a little bit again. I'm going to look at the question one more time. A student's exam mark if they had 20% going in. So I'm looking at 20% on the x-axis. And if I follow that straight up, it looks like it's going to be very close to the same, or about 21%. If you had a student's mark going into the exam, if they got 100% on the exam, now that's on the other side. That's on the other side of our data. I'm going to scroll down here again. 100 on the exam, that's off of the y-axis. That's going to be, well, that one's going to be a little strange. And that question is not worded quite right. It should be a student's mark going on the exam if they had 100 going into the exam. Otherwise, it's outside of our data there. So let's look at 100 going in, 100 on the x-axis, and just follow that line straight up. And it's just under 95, I'd say about 94, which is how this question got answered. So that one is a little bit of a typo. It's asking you almost the same thing as the first one in CI. A prediction like this made outside your known values is called extrapolation. So we had one that was lower than the data we had, one that was higher than the data that we had. But you get the picture: interpolation, extrapolation. This is the last slide here. And you guys, actually, no, I got one more here because we got the assigned work. You guys won't have any issues with this. Drawing lines and curves of best fit, extrapolating, interpolating. It's not a big deal. It's stuff that you've done before in other math classes, I guarantee it. So here's the questions that you're looking at. Page 153, 1 to 3, 5 to 8, 10, 11, 12. Other than your final assessment in this chapter, which is going to be posted on Thursday or Friday, this is it, guys. Just go back and make sure you get this done. So I'm going to have 3 small marks for you in this chapter, just on whether or not you're keeping up with your work, watching the videos, completing the homework. And then you're going to have a final assessment, which, I hesitate to say test, since you can use all your notes and you can watch these videos again if you needed to, but you're going to be cramped for time. It's not going to be 75 minutes like it would be in class, but it's going to be about a day to give you a chance to log on and get these questions done. All right. So that's it for now. Keep the emails coming if you get stuck on these questions, and keep posting your answers, okay?